Good morning, everyone. Am I audible? Great. Good morning. So we'll wait for 5 more minutes. I think only four of you are here, or maybe three. So let's wait for 5 more minutes. Good morning, all. We'll just start in a couple of minutes. Okay. I think more people have joined in now. Yes, everyone, happy Navratri. It's starting today, right? Yeah. Okay. I think we have enough people. Now we can start. Okay. First of all, has everyone managed to finish the assignment? Or before that, the CLT? So let's tackle that first. Okay. Guys, please update. Have you been able to finish the CLT? Did you all get to test it out? This is the same sheet that we are using since last time, okay? Wait, I'll just pause my screen for a second. Sure. What's your question, Sudipto? Good question, Sudipto. We don't have to see when you're using the sampling method through data analysis, you don't have to. Okay, but actually, any kind of sampling has to be random, so it's better not to sort. Okay, unless you have data like that where it will become random once you sort it. So, for example, phone numbers, right? So, if you have a list of phone numbers, if you sort it descending, then you'll get like a random list, correct? So, that's the only case I can think of where you can sort the data. Yeah. Come on, guys. Anyone finished the CLT? Okay. So Dipto has finished it. Anyone else? Should I give you all 5 minutes to complete the thing? Then we'll move on. Okay. I want to start a few new topics today. Guys, please respond on the chat. I can't see you all. I won't know your reactions. I have no idea if you'll maybe dozing off on a Sunday morning. Okay. Done. Gaurav and Sudipto finished. Okay, 4 of you are finished. 5, 6. Okay, I guess everyone is done. Yeah. Only 2 more people need to answer. Okay. So, okay, fine. So we have enough people who've done it. So can you tell me what the difference is, how much difference you all got? So everyone will have different samples, right? But you can always find out the sample of the mean of all these samples, right? And the mean of the actual population, right? Can you all just quickly minus that and find out the actual difference between these two numbers? Paste it in the chat. Then everyone will be able to see, okay, even though we have done it randomly, there's very little difference between these. Okay. So all you have to do is take a mean of all the 30 means that you've taken out. Yeah. And then you kind of minus this mean from that mean. Okay. Just do that much quickly and paste the answer in the chat box. Also, guys, sorry if I sound sleepy. There's little overload of work happening, so I've not slept properly last night. Okay, sure, no problem, Gaurav. Thanks for telling. Come on, guys, how long do you take to minus two numbers? If you're stuck somewhere, if you have some doubts, you can ask. Come on, guys, what happened? Okay, so it's just 42. Yeah, 42. Okay. No, no. Okay. So, good you brought this up. So, Bhanu Singh, what I'm saying is you don't have to do it for each and every sample. Okay. You basically take a mean of all 30 samples. Okay. So, let's say I have some mean here. Let's just take, I'll just take a random average for now. It's the same number, just ignore that. Okay. You will have a list of 30 or like this, correct? Okay. Now, all you have to do is say average of all these 30 numbers. Okay. And basically this average you have to minus from the average of the entire population. Okay, if you want you can calculate that also. So average of this, right? And then you just minus this up. Yeah. So you see how small the number is. I hope everyone's trying this. Okay, minus 42. Perfect. Anyone else? Yeah, it's pretty same. Oh, it's exactly the same. Hey, are you sure all the numbers, all the sample numbers are different? Or are they the same? Just check your formula. It can't be so accurate. Even though this is like generated in Excel, CLT can't be so accurate. Okay. Okay. Got you. From this sample table, right? So this one is just for one sample. Okay. So what you have to do is take a mean for all the samples that you have, not for one sample. Okay, it's for just one sample is what is shown here. Okay. Okay. So Bhanu Singh, that's because you've not pasted as values, right? So you still have the formula on. Okay. But then you should have different values, no? Here. Bhanu Singh, you want to share your screen quickly? I think that'll be quicker. I'll just make you presenter. Yeah, you can share your screen. And everyone else, yeah, we can see it. Okay. See, this is your just one sample, right? You need 30 like this. Okay, I think guys, most of you have done it like this, right? No. No. Okay, I'll share my screen again. Okay, just one second. I'll share my screen again. So what Bhanu Singh has done is just like me. Okay, I just took this one sample just to explain it to you all. Okay, but what you all have to do is actually take 30 samples like this. So if I take the first average, right, I can actually copy paste it as values. Okay, I could have uh, copied it and then copied it and then gone to right click and say paste as values. Okay, then I would basically have to run the sampling again. Okay, so I'll go to sampling. I'll again extract. So my input range would be this. Okay, I need 100 samples, right? And I need the output to be here. Okay, I'll say okay and okay again to replace the data. Now this second sample that I have, uska average, the average for this will go here. Okay, again I'll take the average of the whole thing, right? You see it's a different average, right? I can copy paste this as a value as values. Okay, so now you see they're like numbers, it's not formulas anymore. Okay, again I'll go to data analysis sampling. I just have to click on OK now because all my settings are here anyways. Okay, I got the new sample, I got the updated number here, right? And so on and so forth. I go on doing till sample 30. Is this clear to everyone? Yes or no, guys? Oh. So now once you have this whole list of 30 numbers, right? I'm doing a few just to save time. If I start doing all of this, then you know, It'll just take too much time from the class. Um, so yeah, just make sure you get 30 like this. Okay, so now since I got this number, I can paste this as values. Paste as values. This I'm just copying it down so I don't have to retype the formula again and again. Okay. Oh wait, I think I'm getting the formula wrong. Yeah. Okay, see, so the first one not taken. Okay. So just be aware of this problem, guys. I have to lock this. I hope everyone remembers Excel. You know how to lock this. Okay. Yeah. So once you lock this, then you'll get a good. I think this my sample 2 is wrong, but I'll just ignore it for now. Yeah. Perfect. Shortcut key is F4, just in case you've forgotten. So once you lock this, then you can drag it down easily. Okay. So once I get my sample 3, I'll copy paste as values. Okay. And then I can run the sampling again. Get my fourth one. Okay, that's my fourth one. Copy paste as values. Okay, there you go. So like this, you have to get a list of 30. Okay. Okay. Has anyone here made the whole list of 30 samples? 30 sample means. Does anyone have it? Okay. So Madan, can you just take a average of all the samples and minus it from this and show it to everyone? Okay. So then we can just test this and finish it off.
Hello.
Yeah.
Hello.
Yeah, Madan, we
Sir,
can.
should I share my screen with you?
Okay, yeah, you can share your screen also. Yeah, I'll just make you presenter. Good idea. Yeah, you can share now. We can't see your screen yet. But,
Uh, you have press the button share, but
uh,
it's not working.
oh, is it asking you something? Should I share screen? You might have to click yes or no. Or maybe,
Yeah.
if
Uh,
you're,
uh,
if you're in Chrome, it'll ask you if you want to allow microphone and allow karna padega. You just have to allow access to microphone.
yeah, I have pressed that share also, but
Okay.
it's not taking.
Okay, anyways, just calculate and paste the answer in the chat, no? That'll be quicker.
That I will do. That I will
Oh, thank you.
do.
Yeah. You can mute yourself, mother.
Yeah, yeah.
Yeah, thanks. Anyone else has the whole list of 30 samples? You also can try and paste the answer.
So any provision to mail it?
Mail, as in the whole assignment? No, so this is just
This
as a part
particular
of a
sheet?
class. Sorry, this is just as a part of a class. The assignment that you had, that you have to mail, as in put in the LMS or give it to your
No,
coordinator.
no, I'm talking about the 30 sample that you have told.
Huh.
30 sample
That's
mean that you have to
right.
calculate.
Huh,
That I
correct,
have done.
correct. So right now we just need the average of these minus the average of this, of the population. That's all. That you just paste the
Q
answer.
is coming minus 40,
Minus 42. Okay. Okay. Someone else also got minus
minus
42.
41.
Oh, okay. So you see, it's pretty close for everyone. Even though we are on separate computers in separate places, it's pretty close, right? Someone else also got 42. Bhanu Singh, yeah. Bhanu Singh. Okay. So I'm sure if I do it, I'll also get it somewhere in 40s, right? Even though this sample is completely random for me. Okay. So that kind of proves how CLT works for you. Okay. Okay, I think we should not waste more time. Is the concept clear to everyone? Then I'll move on. Yes or no, guys? Okay. 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 So let's move on. Assignment, was everyone able to finish? Any doubts in this? Any questions? Madan, we can still hear you. So can you mute, please?
So one
Ah,
small question.
good.
Can you please tell me the what's the term
Ah.
for the 30 sample mean
Hmm.
and population mean difference?
CLT. So we are taking a difference only to know how what's the like distance between the two, how different they are. Okay. There's no such term.
Okay, okay,
Huh? But
okay,
if you had to, so standard error, I still have to explain, right? I'll just circle back to it once I finish the doubts for the assignment. Okay.
okay, okay, sir.
Huh?
Thanks. Yeah, thank you.
Yeah. Welcome. Okay. Anyone have any doubts, questions in the assignment? I thought I'll finish this part in the first 15-20 minutes. It's already 25. It's okay. Any doubts here? Was everyone able to understand and solve all these? Is there anyone who still not solved the assignment? Okay, question 6. Yeah, this question I keep getting. So, Ashish, do you know how to like make random numbers, right? It's already given you the formula, and you basically have to put 100. You have to make 100 numbers between 1 and 100. So what I'll do is I basically will I'll just make a new sheet. So I'll say random between 1 comma 100. Okay. So I'll get one number which is between 1 and 100. Okay. Like this, I need 100 other numbers. Sorry, 99 other numbers. Okay. So we get the whole series of 100 numbers between 1 and 100. Okay. Which are all random. Right. So if I just drag this formula down, we have count. You can see the count here. We have 35. So we need few more. Okay. So whatever, you just do this, right? And once you've got the whole list, you just select everything and paste as values. Okay. Because remember, random and random between are all volatile functions, right? So if I make some change somewhere else, you'll see the entire list will change. Okay. So that's all you have to do. So this is called building the series of random numbers. Okay. It's very simple to do. It's just that this kind of trips people up. Okay. The wording, but yeah, it's simple enough. And after that, again, it's the same kind of thing that we've done in CLT, right? So we just have to, instead of 30 samples, we take out 10 samples of 40 numbers each, okay, from this series that you built, okay, and then all you just have to do is make a scatter plot graph, okay. I hope everyone remembers how to make a scatter plot, okay. Just select the numbers, go to insert, yeah, choose scatter plot and just choose one of these, with line, without line, whichever one you need. I think the without line, this first one makes more sense. Yeah, yeah. And because I have not pasted as values, it will recalculate. So you'll see the dots keep will keep moving. Okay. Any other questions, queries? Yeah. So it's uncanny, Every class, it's always these two questions that people get stuck on, and always the sixth one is asked first. I've done so many sessions, it's always the same. I don't know what is up with it. Anyways, so I've made a separate sheet just to explain this fourth one. Okay. So you need 10 coin tosses, right? And you need to count exactly four heads ka possibility, right? So what we need to do is, first we'll calculate the possibility for one coin toss, right? Which is four. Okay. Two possibilities. Sorry. Um, so we have two possibilities. Okay. Uh, for one. Sorry, I think I got this wrong. But you'll understand where I'm going with this. Okay. I think this is two coin tosses. Um, okay. So possibility for 10 tosses is basically two possibilities for one toss, right? And we have raised to 10 tosses. Correct? Uh, does everyone remember this part clearly? Yes or no? Yeah. So same funda. Uh, so we know we have 1024 possibilities. Okay. Um, now we need to know the possibilities for four heads exactly. Okay. So now remember I showed you the combination function, combin. Okay. It'll basically calculate how many combinations you can make. Okay. So I give it 10 and I say out of this 10 we need four heads or tails, whatever it is, right? And it throws out the number 210. Okay. And then you just basically calculate the probability, which is this divided by this. Okay, this is one way to do it. The other way would be binom dist. Okay, that we learned last time. So you use whichever way is more comfortable for you, more convenient. Okay, is this clear? Okay, great, perfect, Diptesh. The answer is same, right? You thought what? Okay, great. What did you think of? Oh, okay. At same time. Oh, like four heads in a row, one after the other. Okay, okay. No, that's not it. Yeah, I know the wording of this question is kind of confusing, but one key difference here is it doesn't say getting exactly four heads in a row. Okay, that is missing, correct? So that's why we don't have to calculate for that. Okay, we are just saying if we randomly flip the coin, if we just flip the coin 10 times, how many percent of the times do we get four heads? Okay, okay, great. What's the answer for the other one, anyways? I'm curious. If you've not deleted it, 0.004. Yeah. Okay. Perfect. Any other questions? And anyone? Diptesh, since you have the calculation already, do you want to just share it quickly uh, through your screen so everyone else also will learn? Okay. Yeah, you can share your screen now. Oh, okay. Let it be. Let it be. It's fine. Don't worry. Um, we can share it next time whenever you're on the computer. Okay. Okay. So I think assignment is done. There are no other questions. I'll just close this. Okay. Okay. So that was CLT today from last time. Now today we are going to start with okay, before I move on, CLT, there was one thing left, standard error. Okay. Now, standard error is simply a measure of like how we found out the difference between all these 30 samples and the uh, uh, mean of the population, right? Okay. Now, Excel will try to guess how within one sample how much of a difference can the mean be, how much of a difference can there be between the mean and all the data points. Okay, that is sample error. Okay, so any chart you have, right, you can actually make, let's see if it works for this. I know it does work for yeah, see error bars. Okay, so it works better in a line chart because you usually get top and bottom error bars. Okay, which basically means, okay, let's make a line chart. Since we just have random numbers, I'll insert a line chart. It'll be easier for you to understand. Okay, I'll go to add chart element and I'll just add error bars. Okay, I'll just add standard error. So basically it tells us, okay, maybe this from the line of average, okay, each data point can move up and down so much. Okay, that's all it tells us. That is standard error. Okay, how different the data points are from the mean. Okay, it's more of a guess though, not an exact number. Okay, that's all. So I think you understand this descriptive statistics fully. Any questions in this, or can I move on to the next new topics? Okay, I think I can move on. There are no questions. Okay, so this time we are going to do uh, inferential statistics. So we've done this much. Yeah. So today we'll be learning correlation, analysis of variance, analysis of covariance, right? Trend line analysis, factor analysis, and this kind of stuff, right? Um, okay. This class might, since we took such a long time, we might have to shift a little bit of this to the next class. But next class, anyways, we have extra time left. There's only one topic to cover in the next class, which is regression. Uh, it looks complicated, but it's not at all. So we'll have enough time to finish all this also. Okay. So anyway, I hope we can finish this much today. That'll be enough. So if I just go to slide 13. Yeah. So I'll start with correlation. Okay. Um, correlation basically means it tries to quantify the relationship between two variables. Okay. So correlation quantifies the extent to which two pieces of information go together, right? So they can either go in opposite directions, or they can affect each other in opposite directions, or they can move in the same direction, or if they can have no effect on each other at all, right? So um, let's take an example. Okay, so if the temperature rises, right? Okay, can everyone hear me? Rajan Patil cannot. Okay, okay. Yeah, Rajan Patil. I'll just type a message for. Please. Okay, okay. I hope you'll be able to hear me now. Okay. So if the temperature rises, okay, what do you think will happen to the sale of ice cream? Everyone? So as yeah, increase, right? So you see how how they are related to each other? Yeah. Okay. Now, as winter comes, the sale of ice cream will decrease, right? So as the temperature decreases, the sale of ice cream also decreases. As the temperature increases, the sale of ice cream also increases, right? So this is called a positive correlation, right? Because when Yeah, when the temperature increases, right? Let's say X is temperature. So when high value of temperature is associated with high value of ice cream sales, it is a positive correlation. Is this clear to everyone? Yes or no? Yeah. Now, can everyone think of a negative relationship, negative correlation? Just one example will do. So basically, it means if one goes down, the other comes up. Demand and supply. Perfect. This is a classic one. Okay. As supply goes down, yeah. Okay, Rajan Patil still cannot hear. Okay, so Sudipta was given one more. Tax cuts of vehicles increase in sales. Yeah. In fact, we saw a good example a few weeks back. The corporate tax was cut by 10% or something, right? And that led to a whole boost for the economy, right? So a negative, yeah, a negative, as in a decrease in the tax had like boom, gave a boom to the economy. Okay, price and sales, yeah. Okay, so that is negative correlation. Okay. Now there is also no correlation, which means whatever happens to these two variables, they don't affect each other, either positively or negatively. Okay. So, for example, if I am having coffee, it has no relation to, okay, that, sorry, I was going to say it has no relation to rain, but it does have. So, okay, if I'm having coffee, it has no relation to, um, um, I don't know how many cars there are on the road, for example. Okay, it has no correlation at all, right? Soya bean. Okay, it has no correlation to soya bean. Okay. So completely unrelated things. Yeah, coffee and soya bean. Perfect. Okay. So these are these three types of correlations. So basically, correlation goes from positive one, okay, plus one, to zero, okay, to negative one, okay. So positive one meaning it is strongly correlated. Uh, if an increase in one happens, an increase in the other has to happen. Okay. Then there is negative. Then there is zero, which is no relation at all. Okay. Then there is negative one, which is as one increases, the other decreases. Okay. And in between, you'll have like percentages. So if there's something like 0.05, okay, or 0.5, let's say, okay, on the positive side, it means um, if if variable x will increase by 1, okay, the variable y will increase by half, right? It has that kind of, it has some mathematical value to it. Okay? If this was 0.25, an increase of 1 in variable x will lead to a 25% increase in variable y. Is this clear to everyone? Yes or no? Okay. So it's also called the Pearson's correlation coefficient, right? This number that we calculate. Okay. So we'll see how to do that in a bit for within Excel, right? Um, so it is not only about numbers. Okay, correlation also is used heavily in ads like this. Like um, basically, you can see what Snickers has done. It's basically correlating hunger to Snickers, right? So it's showing it has all these ads which are related to hunger. Like for example, this I like this one. The zebra, the zebra chasing the lion as though he is going to eat the lion, right? So the whole premise is based on this logic that if you're hungry, you turn into like a wild animal. Uh, okay. So correlation can also be used like this. This is how it's used in popular culture, in like daily life. Okay. So there are a few more examples of correlation in real life. Positive correlation has these ones, right? You can just read through them. I'll give you a minute. Then you have some negative correlation ones. Right now, the third one is what I'm experiencing in the past few days. Okay. So that was correlation. Let's look at how to do it in Excel. Okay. And we have correlation. So in the correlation sheet, it's pretty simple. Okay. Um, if you see this, just go to the sheet. I'll just wait for a minute. Last 4 weeks, huh? Okay. Okay. Once everyone is on the correlation sheet, I'll just explain what this is now. So if you see the x and y variables carefully, you'll see there's a equation going on there. Can anyone say what it is? Hmm. Great. Perfect. X is y is twice of x, right? Perfect. Okay. So y is basically twice of x, and it's true because we've actually just put the formula like this. Okay. So now if I want to calculate correlation on this, all I have to do is use the Corel formula. Okay. So someone has done the whole maths, but you don't need to do this. You say equal to Corel, okay, and you just give it the two arrays. So array one, comma array two, okay. So that this is exactly like perfectly positively correlated. Yes. Now if I try to change some parts of this, let's say I'll make this 8 instead of 10. You see immediately the correlation values have changed. Okay, because now this is not perfectly uh, uh, y is not perfectly twice of x, right? it does not find the pattern matching here in this instance. So it says, okay, now it's not 100% correlated, it's less than that. Okay. And as I go on changing more and more numbers like this, just wait. Suppose I make all of these 8, then you'll see this correlation value drops down considerably. Okay. Does it seem simple to use Corel? Yes or no, guys? Yeah, fine. Okay. Just try this out. Maybe change a few of the Y's and see what kind of correlation is there. I'll wait for a couple of minutes. Okay. Then we'll move on to the next one. Yeah, sure, Rajan. Can you hear me now, Rajan? Okay, sure. Okay. So basically, we had this formula applied here. Okay. Which basically was we just wanted to see the equation. Y is basically twice of x. Okay, that's how this is set up. So now if you try to calculate the correlation, both of these are positively correlated to each other, right? And you can see the entire y series is basically exactly twice of x, right? So if I do the Corel function, okay, which calculates the correlation coefficient, I can give it the two arrays, okay, and it will tell me what is the coefficient, right? So right now it is one which is 100% correlating, okay. Now, if I change one of these, let's take for example this. If I change this to 8, you will see the coefficient will change, okay, because now the entire series is not perfectly twice of this, right? It has some discrepancy in the middle. So it's not 100% correlated, but it's still positive, right? See, even if I put 4 here, okay, just because of one number being lesser than this, it will not make it less correlated, okay? Yeah, that's about it. And if you want, just change a few of these numbers and see how they affect the coefficient, okay? That's all there is to it. So guys, even if I have the same exact number in x and y, it is perfectly correlated, okay? Also, one more thing I want to point out is it works both ways, okay? So even though x could be your normal numbers, if there's a difference in, y could be your normal numbers, if there's a difference in x, it will still catch it, right? So if I make this from 4 to 3, you see the coefficient should have changed. Oh, sorry, my bad, I have to write 8 here, okay? So you see the coefficient did change, even though there's a change in the x, right?
So one small doubt.
Yeah, sure.
Now on the screen the correlation value is 0.983,
Hmm.
right?
Hmm.
Now if x becomes 21, let's assume x
Fine.
becomes 21,
Okay.
y will be 20 plus 0.983, right?
20 plus 0.983. Why would that happen? So correlation is
Correlation
going
is
to be added to this. Okay.
if suppose x become 21,
Okay. I'll
I
put
will
right.
as in I'm trying to estimate
It's a
y.
number. Okay. 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 Say.
X become 21,
Hmm.
y will be based on this data points,
Hmm.
y will be 20 plus 0.983, right? So
Uh,
my
uh,
logic is right.
no, I don't think so. It can't be plus 983. Okay, let's check it out. Okay. So right now there's a difference of 3, right? 8 minus 3 is how much?
5.
5. Okay. So now, since we have this difference, if I add 3 plus the correlation, will it add up to the same amount? Will it become 8?
No.
No, right? So this is what I was saying. So this is more like a percentage value, right? Okay. It does not equal out the two variables. That's what you were asking, right? It does not,
Right, right.
it does not balance out or equal out the two variables. It will just say
Mhm.
uh, what is the relation between these two
Strength
variables.
of relation.
That's it. Okay.
Strength of relation.
Strength of relation. Perfect word. Yeah. Okay.
Okay. Thank you.
Welcome. Good question. So Sudipto is saying that will happen in the case of regression. Sudipto, are you sure regression will help you balance out stuff? Yeah. Predict next value. Okay. Yes. Perfect. Okay. So if you understand correlation very well, then regression will be a breeze. Okay. Even though it looks more complex and there's more stuff to it, regression will be very easy. So make sure correlation there's no doubts at all. If you have anything, just ask now. Okay. So now you know if you want to check for correlation between any two variables, you just have to list down the two numbers next to each other and you just do the correl function, right? So you could maybe have ice cream sales and temperatures, right? Okay. You could have these two headers and just list down whatever happened on that particular day, right? For each day. Okay. You could actually do this in real life, but if you're like, if you want to really try it out. Okay. So it seems no one has any questions with correlation. I'll move on to the next thing. Any, huh, thanks. Okay. So next thing we'll look at is, I wish there was an overview. Okay, before we start with ANOVA and these different tests, we'll basically go through this thing called hypothesis testing. Okay. Okay, actually, I just remembered I have to still show you how to calculate outliers, right? Let's finish that first, then move on to inferential steps. Okay. Uh, so basically, how to calculate outliers? Okay, let's go through that first. Uh, does everyone understand what outliers are? Yes or no? I think last session someone had asked a question where I'd said we'll learn how to calculate outliers. I'm forgetting the question just now. Okay. So outliers are basically the extreme values. Okay. So let's say we have, I'll show to you. Let's take that extra sheet we had. Okay. I'll just turn the error bars off. Error bars none. Okay. Let's take this for example. Okay. Now we have this set of numbers that are charted out, right? Okay. Yeah, Madan had asked for non-performer. Yeah. Okay. So how to find out the extreme values basically? So for example, here 88 I think is the extreme value, right? But suppose you had most of the people who are within this band, and there was one guy who was, let's take a huge number just for the sake of it. You see what has happened to every other data point? Okay, okay, someone's mic is on. Suddenly, a echo point happened. Okay. So you see what happened to the other data points? They're kind of shallow now. You can't really see much difference in it, right? They look mostly same. Just because of this one data point that is really high. Okay. So this would be considered an outlier. Okay. Even if it was in the negatives. So if I say negative 8888, okay, again this guy would be outlier. Okay. Both these in this particular case will be an outlier, right? Clear to everyone? Yeah. So now there's a certain method to okay, this is another good question. So Rajan is saying, is the maximum the outlier? Okay. So right now, what is the maximum number? It's 999, right? Yes or no? So if I say equal to max, what will I get? 999, correct? Even though this number is bigger, yeah, even though this number is bigger, it's in negative, right? So this won't be counted. But still, this will be considered an outlier. Okay. Same way, if I do equal to min, right? Sorry. Okay. It will give me this number, right? But still, even this is an outlier. So it's basically the extreme values beyond a certain band. Okay. It's not the max and min. So you could have another number which is minus 5000. So now maybe these three are outliers, right? But these three won't come in the max or the min. Correct? Okay. So anything that is outside a certain band of numbers is considered an outlier. Okay. So what is that band? How to define that band? How to calculate is what we'll look at now. Okay. It's pretty simple set of steps, and while doing this, we'll also learn of a couple of other parts of descriptive statistics. Okay. Okay. So first we have this list of numbers. I'll just freeze this. I don't like it going on changing. So I'll just paste as values quickly. I have this whole list of numbers. If you want to just like create a new sheet, make a whole list of random numbers from 1 to 100 maybe, and we'll just practice on that. Okay. Just a few numbers will do. So right now I have 20 numbers. Okay. Okay. So I'll just start explaining now. Um, has everyone heard of the term called percentile? Okay. So percentile is basically giving a number, a position to each of these, right? Okay. So now I'll just demonstrate by drawing a line maybe in paint or something. Wait, I think it's better to draw it and just show it. So we are looking at how to calculate quartiles first. Okay. So if I have this particular line here, okay. Now if I divide this into four parts, right? So I'll just divide this into four parts. Okay. Uh, Basically, this would be the minimum. Okay. Okay. Same way, this would be max, right? Now, these lines in the middle, the division lines, right? They are called percentiles or quartiles. Okay. So quartile would basically mean they use percentiles to divide the number into divide the list into four parts. Okay. So our first quartile, okay, because we are dividing the data into quarters, right? Our first quartile, okay, this one is basically equal to 25th percentile. Is this clear to everyone? Okay. So our first quartile is 25th percentile, right? Our second quartile would be how much percentile? 50th. Perfect. Okay. So at the 50th, like halfway through the data, you have the second quartile, right? Then you have the third quartile, right? Which is at what mark? This everyone should guess. 75th. Perfect. Okay. So this is your three quartiles. Okay. Fine. So this makes it really easy to explain to you. Now if I just do equal to QUART quartile, okay, I can actually give an array and say which of these quartiles I want. Okay. So if you see here, it says first quartile, second quartile, third quartile, minimum and maximum. Okay. So if I do minimum, I'll get the same answer as I would have gotten equal to MIN. Okay. Or equal to MAX. Okay. This will be the exact same answer. Then you have these three: first quartile, median value, or the uh, oh, this gave another clue. Everyone remembers what mean, median, mode is? Everyone remembers median? Huh. So that is also the 50th percentile, right? That is also the second quartile. Is this clear? For the same thing, yeah. For the same thing, there's three different names. Okay? Yeah. So let's say I want the first quartile. I'll just use one. Okay. Now I know from my data, this is my first quartile. Okay. Then I can get the third quartile maybe. Okay. If you want the second quartile, you can do that, or you can just say equal to median, right? It'll give the same answer. I'll just do third quartile. Sorry, equal to QART quartile. I'll say three, third quartile, right? Now the difference between these two quartiles, right? This one, this area here, okay, which is between the first quartile and the third quartile. It is called the interquartile range. Okay. Okay. Or for short, it is called the IQR. Okay, just remember this IQR. Okay, this bit here between the first and the third. Okay, so IQR would be wait. I'll just put this here. Q3 QR. Okay, so if I say this minus this, that is my interquartile range. Is this clear to everyone? Hmm? Now, if you can see, we are starting to define a boundary, right? Okay, we are saying, okay, within these two, we'll have kind of a boundary here. Okay, so this is our IQR, right? Which is basically the third quartile minus the first quartile. Okay, this area. Now, to calculate outliers, people generally keep some sort of buffer. Okay, so generally people put 150% or 1.5 times the IQR. Okay, so if I say equal to this into 1.5, that will give me the buffer amount, right? We'll come to why we need this, but just calculate the buffer amount. Okay, this will help us define the bounds. So Rajan Patil, this is a good question. Okay, so 1.5 is just considered general. If you don't know what to do, you just put 1.5, or basically 1.5 times more than the IQR. Okay. Uh, Depending on your use case, you might need more buffer, you might need less buffer. Depends on the data you have. So you can decide whatever you want here. Okay. Is this clear? Yeah. So once you have the buffer, we'll basically add like the buffer here. So the first quartile minus this buffer will give us the bound. Okay, so I'll just make different colored lines so you can make the difference out. Okay. So the IQR minus the buffer will give us the the first quartile minus the buffer, right, will give us this space, this bound, and then we'll have another bound here. Okay. So what we have to do is basically take the lower bound, let's say lower bound. Okay. Our lower bound would basically be the first quartile minus this buffer amount that we have, right? Is this clear? The first quartile, okay, minus the buffer amount, which will get us to some value here. Okay. Same way, quartile third plus the buffer amount will get us some value here. Okay. So our upper bound would be equal to the third quartile plus this buffer part, right? So this would be considered the bounds outside which the data is considered an outlier. Okay. So if there is some point here, okay, let's say there's some point here, some data here, this would be considered an outlier, right? As long as this data point is within the bounds, it will not be considered an outlier. Is this clear to everyone? Yes or no? Okay. So basically just run through these steps. Okay. We have one more to go, but just say done once you're done with these steps. Okay. Once you get the bounds, we'll basically run a logical formula to check whether each of these is outlier or not. Okay. Yes, Madan. I think you're getting the point. So any value less than the lower bound is an outlier, and any value more than the upper bound is an outlier. Yeah, perfect, perfect. So Madan, since if you finish these steps on your sheet, then you can just set a logical formula to check whether if each of these are an outlier or not. Okay, that's okay. Finish these steps and then just make a like logical this function. You can use the if function. You can use the and function. Whatever. Has everyone got the lower and upper bounds? Then I'll show you how to set this up. Uh, Guys, can everyone see the screen? Madan is unable to. Yeah. Madan, maybe you'll have to log off and log back into. Yeah. Okay. Now, okay. Yeah. Maybe the internet was lagging a little bit. Everyone found the upper and lower bounds? Yes or no, guys? At least a no. Or finding or something. Okay. Sudipta was found. Okay. So now all you have to do is just put a function here which checks if it is either lower than this or higher than this, right? So you can do it in a few ways. I'll use the simplest way, which is or. I'll say this should be less than this, or this should be greater than this, right? And I have to make sure I lock these. So this and this, right? So once this is done, I'll just get a true false answer. Okay. If you don't like the true false, if you want the word outlier to come, then you can use the if function, right? If if it is true, then I'll say outlier, right? Otherwise, I'll just put nothing. Okay. Clear to everyone? Okay. So now if I drag this down, I'll basically just be pointed out where the outliers are, whether positive or negative. Seems simple. So the idea of the buffer and the upper lower bounds is just so that you don't cut your first and maximum quartiles and the like the first quarter, sorry, not quartiles, quarter and the third quarter, right? Uh, that's basically it. Okay. Otherwise, you'll basically miss this whole chunk and this whole chunk, which is not really advisable. Guys, let's take a 20-minute break. Is fine with everyone? Yes or no? Okay.
So one small query.
Ah, sure.
So in the sheet, whatever uh, statistical terms are there, like
Ah,
ANOVA correlation,
ah.
portfolio analysis. So beyond this, there is no other statistical techniques that are used in business analysis.
No, this is the base, right? Once your base is clear, you can keep
No,
going deeper into
there is-
statistics. Okay. So when we do regression or maybe ANOVA, uh, right now, see, I can't start with advanced topics, right? I have to start with the basics. So once these basics are clear,
right.
you'll understand how to use these. And once you start to see the limitations of these, then you search for more, like a deeper way of analyzing stats, right? Of using stats.
Okay, okay,
Okay. So there's much
okay,
more
okay.
beyond this. Statistics is a huge, huge topic. Okay, huge subject. We
Yeah,
can't obviously cover all that. So yeah,
obviously, obviously.
okay. So
Thanks.
the idea is if you learn this much, then you should be comfortable with doing some sort of business analysis with this, right? You'll have all the basics in place. That's about it. Okay. So it's 11:26 now. Let's meet back here at 11:45. Okay. In the meantime, those who want to finish the CLT, just finish all the 30 samples and you can practice whatever else you want. Um, Okay. I hope everyone's back. Okay. Okay. Guys, one point I forgot to make with correlation is um, there's this like loophole where um, people think these are symmetrical. Okay. So, for example, uh, the correlation of x to y, sorry, the correlation of x to y and the correlation of y to x. Okay. Um, in most real world cases, this will not be symmetrical. Okay. Like how we have here. Okay. This is not really symmetrical, right? But in most real world cases, sorry, this one is symmetrical, okay, because whatever change we make here into either one of these, they amount to the same coefficient, right? But in the real world, a lot of times you'll find um, x to y ka correlation is different from y to x, okay? So you might have to be a little careful about that. That's the only point I kind of missed out on, okay? Is this clear to everyone? Yeah, okay. So let's move on to hypothesis testing, right? So hypothesis testing is nothing but uh, having an assumption and doing something to disprove it. Okay. So a hypothesis is basically an assumption. Okay. You assume something to be true. That's a hypothesis. Is this clear? So a hypothesis is basically a proposed explanation for a phenomenon. They are generally based on previous observations that cannot be disproved. Okay. So one key thing about hypothesis is they are always about they're they're more like probability, okay, where you cannot be absolutely sure. So there is no for any phenomenon that does not have any available scientific theories which prove it, right? That can come under hypothesis, right? So that's the difference between a theory and a hypothesis. Okay, fine. So for a hypothesis to be a scientific one, the scientific method requires that it can be tested and its validity be established. Okay. So this part basically means this is the testing part. Okay, in hypothesis testing. Basically, any hypothesis you know it's true only after you test it, right? So for any hypothesis to be considered as as a hypothesis, it must be like tested out. Okay. Um, yeah, that's about it. So there are two kind of jargons to this. One is null hypothesis and one is alternate hypothesis. Okay, you'll come across these two very often. So the null hypothesis is basically what you cannot nullify till now. Okay, you cannot see a hypothesis stands true only till the point it is disproved, right? Till then it is a hypothesis. Okay. So that basically becomes a null hypothesis. So for example, if I give you one example, so earlier people used to think the earth was flat, right? Yes or no, guys? People used to think the earth was flat, right? That was the hypothesis, the null hypothesis. Until the alternate hypothesis came that the earth is round. Okay. Now, whenever this was proved, so this is a physical phenomenon, right? So as soon as we went to space, we got confirmed. It became uh, like a fact, right? But till we got out into space and got an external view, it was still a hypothesis, right? So before it being disproved that the Earth is not flat, it is round, that was the null hypothesis, that the Earth is flat. Okay. Um, Another example would be cigarettes, right? So earlier in the 60s and 70s, I think, um cigarettes were considered a status symbol, right? And they were not considered for harmful for health at all. In fact, some there were some like studies done, and it was established that cigarettes are like good for health. In fact, okay, all this was the null hypothesis till it was proven that cigarettes actually do cause cancer, or some they cause harm to you, right? Um, okay, so basically, before we knew the harmful effects of cigarettes, the null hypothesis, the established truth was that the cigarettes do not cause cancer, right? So any medical researcher or someone who's trying to prove otherwise will create what is called a alternate hypothesis. Okay, fine. So what makes the alternate hypothesis? The alternate hypothesis is the opposite or the alternate of the null hypothesis, right? That has been established. In the case of cigarette smoking example, from the perspective of a researcher, uh, yeah, the alternate hypothesis is that cigarette smoking does cause cancer. Okay. Now, to establish this in like a certain quantity, like correlation coefficient, right? We need to put certain number to it, right? That is called your significance. Okay. How significant is the alternate hypothesis? Okay. If it is very significant, then it will basically disprove the null hypothesis, right? If the alternate is not very significant, so for example, if they found, okay, cigarette smokers do not generally get cancer, right? There's no correlation to it. Then the null hypothesis is not disproved, right? Because it's a weak alternate hypothesis. But if they found a lot of cigarette smokers are getting cancer, right? There has to be some correlation between it. Then the alternate hypothesis becomes more and more significant, right? So, at a certain level, at generally 5% or 0.05 is considered a good significance level. This depends on what your data needs are, but 5% is generally considered okay. So, if the alternate hypothesis is like it holds significance of at least 5%, then it is considered worth pursuing, worth seeing what is there in the alternate, right? If it is not even 5%, then you don't even consider it. Less than 5%, okay? So if you see the p value here, okay, p value stands for probability value, right? This is the significance that I was talking about, okay? So in hypothesis testing, an attempt is made to reject the null hypothesis and accept the alternate hypothesis, okay? Uh, Yeah, so there are all these different methods which basically deduce the relationships between variables and across all variables. Okay, so within each variable and across all the variables, right? They all rely on the eventual p-value outcome. So this is a significant number that we'll be looking at, right? Um, so if you just read this chart, right, it says p-value greater than 1%, get greater than 100%. Okay, it will not hold much significance, right? But as the percentage drops, right? Let's say it becomes less than 50%, okay? Then it is really, sorry, 50% is, sorry, I read this wrong. This is 10%. My bad, not 100%. If it's greater than 10%, you don't even like consider it much. But as the significance drops, let's say at 5% or less than 5% actually, then it is considered significant. As the number drops, it's considered more and more significant. Okay, the alternate is considered more and more significant to pay attention to, right? So a lot of times people confuse the p-value as being an absolute answer. Okay, it does not mean the alternate holds true. Obviously, it's just like a indication. Okay, okay, how much weight does the alternate hypothesis have? That's all the p-value is trying to tell you. Okay. Someone wanted to speak, right? The mic just came on. Okay, I think that was a mistake. So, any doubts and questions regarding this hypothesis testing? Oh. So, can everyone craft like one sentence, one null, and one alternate hypothesis for whatever topic you want? Can everyone do that quickly? No, Madan, you got the question wrong. So we have to say, we have to construct a like sentence, a null hypothesis. Okay, this is your null hypothesis. Okay, okay. Height and weight are directly proportional. Okay. And then what would be the alternate? Yeah. Okay. So I'll just type a short sentence. This particular hypothesis that I've given example is wrong. So I've written null is it will not rain today, and my alternate hypothesis is it will rain today. Okay. Now will means it's an absolute surety, right? Okay. Um, in hypothesis testing, nothing is sure, just like probability. You can say it may rain today or it may not rain today. Okay. If you use absolute terms, it's not a hypothesis statement. Okay. Okay. So Dipto has given one more. Drinking and driving does not cause accidents. That's your null. Okay. Perfect. Good example. Okay. Mass is proportional to weight. Okay. Mars has no. Okay, that's a really creative one. Mangalyaan is still stuck in everyone's head. Huh? Mars has no water. Yeah, true. Okay, I think everyone's understood how to do this. So let's just go to Vikram landers. Is it? I lost track of it. Sorry. Yes.
Sir, you showed the table wherein p value
Hmm.
10%, 20%, all those things are there.
Hmm.
If p is 10%,
Hmm.
we should accept the null hypothesis, or probably we should reject the
That's
null hypothesis.
that's what I'm saying. So p-value is always just an indicator of where you have to go.
Right,
Is it worth pursuing or not? Okay. So if you get 10%, let's
right.
say, right? If you get 10%
Uh,
significance, That means, okay, the alternate hypothesis is not so strong that it can reject the null hypothesis. Okay, but if you have
Right.
something like let's take 0.03%, right, or 3%, um,
Huh.
then it means it holds a lot of weight. The null hypothesis may not be true. We can reject it most of
Okay.
it. Okay,
Okay. Okay.
okay.
Thanks.
That's, mm, yeah, that's about it. There's nothing much to practice in this, but once we go to ANOVA, let's say, right? Now in ANOVA, um, okay, hypothesis testing was just the theory part. Now when we come to actually measuring this kind of stuff, right? That is done through ANOVA and ACNOVA, right? Yes, it is like confidence level. Yes. How to compute P? We'll look at that. We are looking at that. So ANOVA and ANCOVA will help us to do that, right? And you don't have to go through a lot of complicated maths. You just use the data analysis tab, right? Okay, guys. Descriptive analysis was simple enough for me to go through a little bit of maths, right? But if I go through maths for the rest of the topics now, it'll feel too heavy, and I don't know half the stuff because see, just knowing the maths is not very helpful for business, right? You must know how to use this more importantly. Okay, so we'll pay a little more attention to that, right? If you want to understand how the maths works behind all of this, then you can always research online, right? But I would say start with getting an understanding of how to use it. Then you will maybe perhaps feel the need to learn how to compute it. Okay, fine. Coming to ANOVA. So we have this situation here which basically says we have three types of ads that we run. Okay, one is magazine ads, then we have web ads, and we have newspaper ads. Okay, and basically we want to see what is which one of these will like be most effective, right? Okay, so for example, if you see this table here, right, you have the basic summary of descriptive stats here for magazine, web, and newspaper ads, right? Then you have the ANOVA, which is nothing but the analysis of variance. That's the full form. Okay. Now, analysis of variance means it'll basically try to see how uh, it'll analyze the difference between all of these, the variance, right? Uh, so, for example, between each of these groups, there's some there's enough difference to consider, right? This p-value is less than 5%. Yes or no? Yeah. So now, if you let's assume this data was real life data, and you found out that the difference between the groups, the p-value is just about 20%. Let's catch, okay, or 0.2, right? Then would you kind of uh, want to remove one of these, right? You want to okay, I'll explain the situation in a different way. So this company wants to stop one of these streams of advertisement, okay, and it wants to know which is the weakest one: magazine, web ads, or newspapers, right? That's the idea here. Now, if you want to check the difference first, you basically have to see, you basically have to compare all three, to find out if which one is the weakest, right? So if you want to see the difference between each of this, that's when you go to p-value, right? Right now we know
So,
there is some difference here. Yeah, man.
this 5252, 5595, what are all this?
Okay,
Sales
this
figure or
we
what?
won't get into. This we won't get into. Okay, these are other measures. So, for example, this one I think difference in. I'm not sure. I'll tell you the F and F critical. Okay, so F value is
Me,
like,
day
sorry.
one figure,
Acha,
the table that is there,
oh,
data.
okay, okay, okay. I'll explain this. Okay. I thought you were asking about this. Okay. So day one,
Right.
yeah, I'll explain this. So day one, magazine, so many people came in through magazine ads. Okay. Day one, again through web ads, so many people came, and through newspapers, so many people came, or called, or whatever, right? Basically, this is the amount of queries it has generated. Okay. Day two, again, this is the amount of queries each of these have generated, right? Day three, this is the amount of queries each of these have generated. Okay. Um, yeah, fine. So yeah, F and F critical are kind of like a precursor to p value, right? So if you understand p value, that's enough. You don't have to get into all of this, right? For now, at least. Yeah. So right now, if I can see there is some significant difference between all three. That's how you get to know. Okay. That's what the ANOVA is for, right? So to calculate this, we'll just go to ANOVA, go to Data Analysis tab. I don't need to select actually Data Analysis add-on, and basically we use the t-test. Sorry, ANOVA single factor. Sorry, we use the ANOVA single factor test, right? Basically, this will become my input range. Okay, I'll say labels in first row, and I'll put my output here somewhere. Okay, and the moment I press OK, it will give me the same sort of table here. See? Okay, so you have the basic summary of this descriptive stats, and then you have the ANOVA with the p-value calculated for you. Okay, just try this much, everyone. Just calculate the ANOVA. Say done once you're done. Okay. Okay. Sudipto asking what is the alpha value 5.5? Okay, in the data analysis tab, in this one, right? Huh. So this is where you set the significance level that you want. Okay. So generally, as I said, default is 5%, right? But sometimes, suppose you're working for airline or military, then you want to be more sure of what you're doing, right? So maybe this might be at 99%, or like zero, or like a higher, lesser percentage, basically, right? So this might be at 0.01. Okay, so 1% confidence you need, right? Bhanu Singh says my p-value is different from the initially calculated one. Let's see if ours is different. Just cancel mine. So ours is exactly the same. So Bhanu Singh, just make sure you selected the proper data set for, yeah, I think you must have missed some numbers from in the selection. Okay. So when you go to the single factor ANOVA, you make sure you select this properly. Okay, that could be one reason. Oh, by the way, if your data set is the other way around, you can say it is grouped by rows. Okay, so this doesn't make sense, but I'll just show it to you anyways. If I select data analysis, and let's say I want a day-wise breakup, right? Instead of a stream-wise breakup, then I can set this to rows and keep and kind of use this. Okay, so now this will give, like, for each day it will give you the summary, right? And the p-value is really higher because obviously this kind of data doesn't make sense, right? So see, this is a good example of it showing there's no like relation between each day's uh, output. Okay, is everyone done with ANOVA? Yes or no, guys? Yeah. Okay, Madan, what is that? Okay, it seems your so D. Okay, don't take the days, right? Okay, Madan, just take the numbers that have to be calculated, right? This is why your p-value is different. Okay, don't take the D column, just this much. If you want to take the labels also, okay? Because see,
How to do that?
sorry, how to do that?
Actually, I got stuck. I got stuck when I'm selecting from 1 till 2 to 5
Huh,
while running the ANOVA single
huh,
factor analysis.
hmm,
I'm able to generate output, but the word like group like magazine,
huh.
web,
I'll show you. I'll show you.
ads,
I'll show
newspaper
you.
is necessary.
Understood. Understood. I'll show it to you. So when you go to single factor, right? Uh, you make sure you select it properly. So I'll take from magazine. Okay. I'll make sure to take the headers also. Okay. That's how the this data analysis pack will know that this exists, right? And then you see this check marks, labels in first column. Make sure this is checked. Okay. That's about it. So when I say OK now, you will see. Okay, I'll have to set another output range. I'll just do that quickly. I'll just put this here. I selected. Uh, oh, sorry. I had to set this to columns, right? I had to. That's what my mistake was here. Okay, fine. So now when I say OK, it will basically come with the names here. See, if I had not taken the labels, right? If I had not selected this, if I had selected only the numbers, then the labels can't come. Okay, then it might say variable 1, 2, 3 or something. Okay, Madan. Okay, so Deepto is saying my p value is 0.895. How come it's so high? Uh, I don't think the data is different because I've just taken this from the LMS only. Just check. It's only this data. So Sudipto, just ensure you've not taken the day numbers. Okay. and you've grouped by columns, okay, not by rows. Because your p-value is really different. Mine is 3%. Yours is 80% something. Sudipto, you found the like issue? Okay. Okay, you can figure it out a little later, maybe. Um, Anyways, I'll just move on. So remember I said they want to like kind of discontinue one of these streams of ads, right? So now how to decide? Now we've established there is some difference between these three groups, right? And there's a significant enough difference for us to bother about it, right? Because our p-value says, okay, it's less than 5%. So we should value about it. So we should investigate further now, right? So now how do we know which of these three to keep and which of these three to remove? Okay, that's the next step, right? Now to find this out, we'll have to compare each with, we'll have to compare each of this with each other, right? So that is done by the t-test, okay? Paired two samples for means, okay? So let's try that out. Mm, yeah. So again, I'll go to data analysis. I'll say t-test, the first one, okay? Paired two samples for mean, two sample test for means. Uh, so now variable one, I'll take maybe magazine and web ads, right? I want to compare magazine versus web ads. Um, I'll say I have chosen the labels because I did select magazine and web ads. My output range could be this for now. Yeah, and I'll leave my alpha at 5%. Okay. So now I have this whole table here, which basically tells me what is going on. So here, if you see carefully, you'll get this one tail and two tail test. Okay, you'll get two p values this time. Just try this out. Just do this test, and you'll start to get two p values. Okay. Sorry, just randomly somewhere music started. I'll just mute myself. Once you're done, I'll explain the difference between these two p values, p tests. So right now I've just taken magazine versus web ad, but you can take any two. So because we have three streams, we'll be comparing them like against each other one by one. Okay. We can compare only two at one time. So we've taken magazine versus web ad. Then we'll take web ad versus newspaper, and then whoever wins from here, we'll take those two. Okay. Yeah. Has everyone been able to get this done? The t-test for two meals? Yeah, for two samples. Okay. So I'll just explain how this works. So basically, we'll compare magazine and web ads, right? Now we need to first look at the significance. How significant is this, right? Is it worth looking into first? Is Can everyone tell me, is this a significant difference? Yes or no? Okay, Rajan says yes. What about everyone else? Okay. So basically, another number you know here is the correlation value, right? So how is it correlated? It is a very small correlation actually, just in a negative way, right? Now this two tail thing and the one tail thing, I'll explain what that is. Um Basically, if you don't want to understand anything, one tail is basically checking for one against uh, it's checking for one against the other, right? But the two tail will also check for this second one against the first one, right? It'll do both the tests, vice versa, and then it'll give you another number. Okay, that is the two tail test, right? So in general, just remember the two tail test is a little more reliable than the one tail test p value. Okay, is this clear to everyone? Okay. So now the two-tailed test is basically a little better judge. So according to the two-tailed test, is this worth pursuing? Yes or no? Is the difference enough? Yeah. Okay. So magazine and web ads, there's enough difference. Same way, let's find out what's the difference between web ads and newspapers. Okay. So we finished these two. Now let's check for these two. Okay. Just try it out. You should come to this kind of table. Done, everyone? Hmm. Okay. So now for this one, you tell me, is there much difference between web ads, newspapers? Is it worth like looking into?
Uh, Sorry, sir, to disturb you.
Yeah, it's okay.
So the week 9 sheet data that is there in
Sorry,
ANOVA
which
and week 8 sheet, I am talking about the week 8 sheet for practice and week
okay.
9 sheet for practice.
Huh,
The data in the table
huh,
of ANOVA, the
huh.
values are different because of which uh, some people are getting different p values, including me.
Okay, okay.
Those using week 9,
So these values are different, you're saying?
ha.
Oh, okay, okay.
For example, Bhanu
So,
or someone
so
was
just
getting
before this
different values.
batch started, I just downloaded a fresh copy from the LMS. So just to make sure everyone has
Just
the
for
same.
your information.
Yeah.
Just for your information. That's it.
Okay, okay. Thank you. No problem. Okay, that's funny. I'll just have to ask the coordinator. Yeah. Okay. Um. So Bhanu Singh says, hmm, So even he has a quite a big number, right? So what I'm asking is this difference worth pursuing also? Yes or no? Come on, guys. It's pretty simple. Just see the significance level. Is there a significant difference between web ads and newspapers? Okay, Bhanu Singh is putting his numbers. Fine. Okay. So magazine versus web is 0.73. Web versus news is 0.82. And then we need one more, right? Magazine versus newspapers. This is a really huge difference anyways. Mine is showing 0.38 and yours is 0.82. Okay, Bhanu Singh, are you doing the third one? I wanted to use your chart as an example. Okay, done, but put the significance level, no? The P test, the two-tail one for magazine versus newspaper, like you did for the other two. Yeah, thanks. So it says 0.67. Okay. How come they're all so high for you? None of them are significant in your case. That's weird. Uh, Guys, is everyone getting the same numbers as Bhanu Singh Rathod? Yes or no? Or is it more similar to mine? Yeah, this one. Same file. Okay, maybe. Okay. I'm using the Excel 101. Maybe that's why. Hmm. Okay, so let's go to Anuva. Yeah, yeah. Okay, these numbers are different. My bad. Sorry. Really sorry, guys. Uh, I just assumed the sheets were same. Really sorry. So, okay. So let's do the tests here. I'll just run them quickly. Okay. Then I need one more for. This is newspapers. Okay. And then finally one more for magazine versus newspaper, right? So this would be magazine versus newspapers, and this would be okay. So I got these now. Okay. Yeah, I think I'm getting the same numbers now. Yeah. So now out of these, which one do you think should like just looking at the numbers? Now you understand how to read significant level, right? Yeah. Bhanu Pratap, I think we have the same numbers now, right? I'm using this newer sheet. Okay. Uh, yeah. So out of these, just looking at the paid two-tail test, right? Which of these do you think will you pursue? Come on, I'm asking everyone. Which of these do you think is worth pursuing? Okay, why do you say that, Bhanu? Web ads and newspapers. Okay. You will drop one of these, you're saying, right? Okay, keep. Okay, then which will you drop? So okay, Bhanu, even if you want to keep, why? What makes you say you want to keep this combination? So basically, you want to remove the magazine ads, right? What made you say that? Hmm. If you want, you can turn your mic on and speak. P value is closer to 100%. Okay, okay. So this is the biggest P value you're seeing, right? Okay, perfect. So what does that mean? In other words, it means there's not much difference between newspaper, web ads and newspaper, right? There's not a significant difference, right? Yeah, perfect. Okay. So this though we cannot remove. If we have to see the performance of magazines, right? Now see, this is one mistake people sometimes make is just based on this they'll take a decision of removing magazines, right? But no, this is just an indicator. The p-value is just an indicator. It says, okay, we should look at magazine sales versus everything else. Magazine response versus everything else, right? Sorry. Um, Also, another thing you could, okay, now this is where you actually see the numbers, okay, and understand which one to keep, which one to not keep. Okay. Now you will basically have a uh, like a target to check for, right? Now I know magazine, I have to kind of just look at the figures properly. Okay. That's what this number is basically trying to tell us. Okay. Clear? I think Bhanu Pratap has got it, Bhanu Singh has got it. Anyone else who is not clear on this, I'll explain again. Everyone clear on how we arrived at magazine? So in a real world scenario, I took under consideration of average queries and p-values. Okay. Okay. Oh, so you took the average also, the mean. Perfect. Perfect. So you're using the rest of this also. Perfect. Yeah, true. The average for magazine is the lowest anyways. Good. Sure, Ashish. So, is the p-value clear to you, Ashish? It just means how much of a significant difference there is, right? Now, if you see the p-values, let's take the two-tail one because it's a stronger version. Okay, let's just take these three numbers. Okay. Now, magazine versus web ads, you have some difference. Okay, 0.73. Okay, web ads versus newspaper, you have 0.82. Okay, and magazine versus newspaper, you have 0.67 difference. Okay. Now, magazine versus newspapers has the most difference. Okay, this could be in a positive or negative way. We are not bothered about that now. But there's a lot of difference here. It's a significant difference, more significant than these two, right? You agree with this much, right? Yeah. So now we know magazine and newspapers have very different numbers, queries. Now, if we look at magazine and web ads, for example, that also is different, but what what is the least different? What generates the similar amount of queries is web ads and newspapers, right? They're quite similar. It's closer to 100%, right? It's 82%, closest to 100%, right? So I can say these two are mostly on par. Okay. Only thing lagging behind is the magazine. Okay. And you can also look at the means to confirm this. See. Now the mean is what will tell you whether magazines are doing much better than newspaper and web ads or they're doing much worse. Is this clear now? So because the magazine ka average is lower than newspaper and web ad, basically I know magazine is what has to go out. Is it clear now? Okay, great. Anyone else? Any questions? Welcome. Okay. Madan, yes. Why meaning you have some question? Madan is asking a lot of questions today. He's asking, he's enjoying today's class. Good. Okay. So now I know magazine has to go out from here. Yep. Good. Okay. Fine. So let me see. Aknova. Actually, this I'm just thinking I'll take up next time because we just have 20 minutes left. Mm, okay, guys. I think Ankova I'll take up next time. There's too little time left for this. Okay. So if you all have any doubts, you can ask. Maybe finish solving the assignment if you have not yet. Um, I think we've done most of it. All of this will come for next session, right? The portfolio analysis, trend line analysis, PCA, and regression. I can't see that. So these parts we'll do next time. Okay. So we have 20 minutes left. Mm, uh, I'm thinking whether should I start it or not. Actually, it's better we do it next time only, right? Even regression is not such a big topic. We'll be able to finish both next time. So in the meantime, you can start solving the assignment, or you can ask questions, or you can just practice whatever you want. So in short, Ankova basically, I missed last assignment part. Yeah, sure, I'll repeat that. So I just finished this summary of this. Ankova is basically, see, ANOVA lets you know uh, there is some difference, right? Ankova will basically let you know how much of a difference there is, where the differences are basically. It's a little more detailed version of ANOVA. Okay, fine. So Rajan, we want to do which part of the assignment did you not get? Uh, Session one assignment. Okay. So which part did you miss? Rajan? Question 1 to 5. All of them. Okay. So write all possible outcomes of tossing two coins together. So this will be heads and tails, right? Four. Huh. But you have to write, okay, you could write four also, or you could write all the possible outcomes, which is heads and tails and so on, right? Then what is the probability of getting a king from a deck of hearts? This I think we solved something similar in class also last time. So how many cards in a deck? Okay, 51 or 52? Oh, okay, so from 52, um, yeah. So from 52, how many kings do you have inside the? How many kings of hearts are there inside a deck? Four. One. Okay. Let's check. Okay. So let's take the. Where is that? I have an image with cards. Yeah, playing cards. Okay. Just look at this image and count. How many king of hearts you have? Okay. Just one, right? Two. Okay. There's confusion even after looking at this. Okay. So you just divide that by the total number of cards. Simple. That'll give you the probability. Okay. So what's the answer to that? If you divide it by the total number. Sorry, this one. Yeah. 1 by 52. Perfect. Gaurav, why do you say 1 divided by 13? 1 divided by 52. Which comes to what? 0.192. Okay. So it's asking for king from a deck of hearts. So can you just have a deck of. Okay. Valid point. Yeah, I understand what you're saying. So Gaurav is basically not counting the entire deck. He's counting, let's say you separate only the hearts out. then what's the probability, right? Perfect. Yeah. Okay. Okay. Same way, what's the probability of getting a king and a queen from a deck of cards? Is it the same, right? So it's not asking you the what is the probability, right? It's asking you, is it the same? So yes or no, right? So you have, I think, equal number of king and equal number of queens, right? So it should be yes. Okay. Yeah. And then what is the probability of getting exactly four heads in a toss of 10 coins? That again I showed here in that uh, sheet is helpful. Yeah. So you have 10 coin tosses, you need four heads, right? Um, for let's take 10 coin tosses, right? You basically uh, put how many possibilities are there for each toss and then raise it to how many ever tosses you want, right? That'll give you the total number of possibilities. Okay. For 10 coin tosses, it is 1024. And then you need to count how many possible ways there are for four heads to come up, right? So you use the combine function, which lets you select the total number and the chosen number of heads or tails or whatever you need to count, a specific number, and will give you how many combinations are possible for that, right? So this is 210, okay? And then I just divide this 210 by 1024 to get the probability. Is this clear? Yeah, Rajan? Yeah. Okay. The other function you can use to do this is the binom list function, like we discussed last time. Number, trials, probability, and false. That's about it. And then fifth question is calculate the descriptive stats of the following. So this series, you'll have to put it into Excel, right? Yeah, so it's up to different people prefer different methods. You use whichever one you want. So Gaurav prefers binom. Okay, up to you. Um, okay, so this following series of data, you just type it into Excel or copy paste it and use text to columns. Um, and yeah, and just run the data analysis part. So if I just go to that extra sheet I'd made, or I'll just do it here for now. You go to data analysis, and you do descriptive stats. Okay, and basically you just have a list of all the descriptive stats here, like how we have done this for one of these. Yeah, no, not this. I can't find the sheet. Okay, I hope you get the point, Rajan. Okay, and the rest is easy, I think. Yeah, welcome. So, guys, I hope I'm not making stats like difficult to understand. I hope it's becoming easier to understand. I'm just trying to focus on the key parts. I'll just copy paste my feedback link quickly. Mm, And also, if you've not completed your assignment, just finish it off now so that you can send it. This is my feedback link for today's class. Oh yeah, Geo has started, right? There. Okay, great. Pretty good. Okay. If you have any questions, you're stuck somewhere with the homework, just ask. Okay, bye Rajan. Happy Navratri. Everyone give me a proper population full of feedback sometime, at least once. Only like 3, 4 of you keep giving feedback. Okay. Yeah, Gaurav, sure. Unless someone has questions, I'll wait till 1 o'clock. But the rest can leave. It's fine. Welcome. Um, well then, yes, there is. But it's more into like machine learning stuff. Okay, so we won't be covering that today. Wait, let me look it up also. Yeah, see, it's more into machine learning. We won't be getting into that. Welcome. By the way, if anyone is interested in machine learning or artificial intelligence, then you'll have to get really good at stats. That is there. Just paste the link here. So Bhanu Singh, you're going to learn that, is it? Mm. Okay, guys, a minute left. I'll end the meeting at 1. Okay. See you next time. Do whatever you can do of the assignment. Rest will finish next time. Okay. That'll be our last session together, and then you'll go back to Rushabh. Yeah. Okay. Bye, guys. Okay. I'm ending the meeting for all. Bye.